Chapter 14, Part 2, a 2x3 two-factor ANOVA. Question asks, the following results are from an independent measures two-factor study with n equals 3 participants in each treatment condition. Use a two-factor ANOVA with an alpha level of 0.05 to evaluate the main effects and the interaction. Calculate the effect sizes for the main effects and the interaction. All right, so you have 2 levels of factor A, 3 levels of factor B. We're given T of each cell. We're given SS of each cell. First step is to compute SS between treatments. That is the sum of T squared divided by little n, which is how many participants are in each group, minus the grand total squared over big N. We do this by taking each T value, squaring them, and dividing by the number of participants in cell. So as you could see, that's 9 squared divided by 3 equals 27. 18 squared divided by 3 equals 108. 27 squared divided by 3 equals 243. 9 squared divided by 3 equals 27. 36 squared divided by 3 equals 432. And 45 squared divided by 3 equals 675. Minus the grand total squared divided by big N, or the total number of participants in the study. When you add up all of these values and subtract it from 1152, you will get 360. That is SS between. For SS within, you simply add up all the SS's that are given in the matrix. 14 plus 26 plus 8 plus 8 plus 8 plus 14 plus 26 equals 96. That is SS within. For SS total, you take the sum of x squared, which is given and is 1608, minus the grand total squared divided by n, which we just did, which is 144 squared divided by 18 equals 1152. 1608 minus 1152 equals 456. You can also check your work by looking at SS total minus SS within, and if that gives you SS between, then you did your work correctly. And if you do 456 minus 96, you will get 360. The next step is to get SS of A. So you're going to take the T squares of rows divided by n rows. So if you go up here, there are 3 rows. And if you add up all the T's in that row, you will get 54. And the total participants in that row is 9. 3, 6, 9. You do that for both rows. So that will come out to 54 squared divided by 9 equals 324, plus 90 squared divided by 9 equals 900, minus the grand total squared divided by big N, which is 1152. 900 plus 324 minus 1152 equals 72. SSB. You take the T squares of the columns divided by n columns. The T squares of the columns are, in the first column, 9 and 9. Second column, 18 and 36. Third column, 27 and 45. There are 6 participants in each column, 3 per cell, 2 cells per column. So if you do 18 squared divided by 6 equals 54, 54 squared divided by 6 equals 486, and 72 squared divided by 6 equals 864, minus 144 squared divided by 18, or the grand total squared divided by 18, which equals 1152, and that equals 252. The last sum of squares you need to compute is SS interaction, and that equals SS between minus SSA minus SSB. That's 360 minus 72 minus 252, which equals 36. If you got a 0 here, that would mean there's no interaction. If there's any number there, we have to test if that interaction is significant later on. Now you have to get your 6 degrees of freedom. So df between is simply the number of cells minus 1. There are 6 cells. 6 minus 1 equals 5. df within is the sum of df in each cell. There are 6 cells, 3 participants per cell. 3 minus 1 equals 2. 2 plus 2 plus 2 plus 2 plus 2 plus 2 equals 12. Or 6 cells times 2 degrees of freedom equals 12. dfa is the number of rows minus 1. There are 2 levels of the row of factor A, male and female, so 2 minus 1 equals 1. dfb, number of columns, minus 1. So you have 3 factors in the column section, factor 1, factor 2, and factor 3. So 3 minus 1 equals 2. That is how you get dfb. dfa by b, or df interaction, is df between minus dfa minus dfb. So if you do 5 minus 2 minus 1 equals 2. Here I did df between minus dfb minus dfa, but no matter what order you do it in, you'll still get the same answer as long as you start with df between. df total is simply df between plus df within. So df between is 5, df within is 12, so df total will give you 17. Now you just take those values and you put them into this ANOVA table. So I plotted all the sum of squares that we just solved for, all the degrees of freedom that we just solved for, and now we are going to get the mean squared for source A, B, A by B, and within. You do that by doing SS divided by DF. So for A, 72 divided by 1 equals 72. For B, 252 divided by 2 equals 126. And for A by B, 36 divided by 2 equals 18. And finally, for within, 96 divided by 12 equals 8. Next step, we have to get the f obtained for those 3 factors. You're always going to be dividing the ms of each factor by ms within. So 72 divided by 8 equals 9. 126 divided by 8 equals 15.75, and 18 divided by 8 equals 2.25. Now you have to get the f criticals. You do that by using the degrees of freedom of the factor that you're looking at, and always using as the second degrees of freedom df within. So if you go to the chart and go to df of 1 and 12, you will get 4.75. If you go to 2 and 12, you will get 3.88. And again, if you go to 2 and 12, you will get 3.88. Now you can look at these values and see what's significant. 9 is greater than 4.75. So factor A has a significant effect. 15.75 is greater than 3.88. So factor B has a significant effect. 2.25 is less than 3.88, so the interaction effect is not significant. The final step is you want to get all 3 effect sizes. You do that by using the formulas below. For factor A, you do SSA divided by SSA plus SS within. That is 72 divided by 72 plus 96 equals 0.43. For effect size B, you take SSB divided by SSB plus SS within. That is 252 divided by 252 plus 96 equals 0.72. And effect size A by B equals 36 divided by 36 plus 96, which equals 0.27. You plot those on the ANOVA table, and now you have completed your ANOVA table. We could see that factor B has the largest effect size. We could see factor A has the second largest effect size, and the non-significant factor interaction has a low effect size of 0.27. This is how you complete a two-way ANOVA on a 2x3 matrix. This is what you will be given on your exam at the end of the semester. Please review this video and do the question step by step, and good luck.